All right, hello everybody. Hi. Hey guys. We're gonna now look at how we can solve some differential equations using the technique of separation of variables. Exciting! Hooray! Hannah's really excited. I am. Okay, let's get going. So, the differential equation is basically an equation where you're given the derivative already. So we're going backwards to like the function. So like back in the beginning days of high school and your math life, you would start with you would start with the multiplication table, then eventually you learn how to solve equations like y equals 5x plus 10, all that. But now we're going to go ahead of that, and we need to go back to those equations because actually in real life, differential equations are actually more common to find than the function of something. But we'll get into that more because I know you guys want to just learn how to do this, or at least some of you maybe. But enough of me talking, more action. So we have my staff, my wizards. Okay, it's called separation of variables because you want to put the variables on separate sides. So depending on what you have on the numerator, we have dy in the numerator on the left. We're going to bring the y's to the left, x to the right. So multiplying both sides by their opposites. So kind of like cross multiplying, but if you want to think of it that way. So in just one shot, we'll have y dy is equal to x dx. So keep in mind that the dx and dy have to be on top. Now, just a side note, it's going to work with the same properties as you would be dealing with fractions, but just know and believe me when I say these are not technically fractions. And yes, though, you're going to be treating them like fractions because you're going to be able to divide and do all that, fraction stuff. But for your practical purposes, they are. But anyways, now that we got the y's and x's on the opposite sides, we're going to throw in the integral operator. So we're going to integrate. This is a little messy. You got to do a better job than this. I got to hold myself to a better standard. A little better. Okay, so we integrate simple ones because this will just be the reverse power rule. Y squared over 2 is equal to x squared over 2 plus a constant c. And we got to just isolate y by itself. So multiplying both sides by 2, these will cancel. So we have y squared equals x squared plus c. Take the square root of both sides. And we go y equals, let me take the root of both sides. We got y equals plus minus the square root of x squared plus some constant c. There we go. So a general solution, because we don't have a specific value for c. So it's going to be a family of solutions. And we'll look more into that when we do some word problems coming up. Next, we got dy dx equals 3x squared over y squared. So multiply to the left by y squared. So we have y squared dy. I like throwing that dot there to remember that we're multiplying, even though the textbooks don't usually do it. Maybe they don't like to spend ink. And the right side by dx. So we have 3x squared dx. Now let's throw the integral operator. Whoa, what's the long one? That's what she said. I'm just kidding. Never mind. Now let's integrate. So y cubed over 3 is equal to 3x third over 3 plus our constant c. These 3's cancel. We have cubes again. Multiplied to the left by 3. We have y cubed is equal to 3 times x cubed plus c. Let's call this c1 because when you multiply by 3, you're going to get another constant. And that reminded me of something that I multiply. Oh yeah, so here I should have technically done this. I'm multiplying both sides by 2. Then this c, if I call this originally, let's call this c1 originally. Then this is going to be a different c. That'll be c2. That was my bad. Sorry about that. It's okay. Thanks, Panda. His name's actually Pepe. Well, I don't want to get dirt. My hands are. I gotta keep them fresh. All right. This now. Let's rewrite this as y cubed equals 3x cubed. We'll call this a different thing. We'll call this c2. So a different constant. Now we just take the cube root of both sides. So y equals the cube root of 3x cubed plus c2. And there we go. That's our answer. Nice. Oh yeah, it's up there. Duh. My God. I got burp. I gotta stay focused. Okay. Here we got some more action. As you can see, we have the 5y and the dy dx grouped together. So let's subtract x squared from both sides. So let's have then, we'll have 5y times dy dx is equal to negative x squared. Oh, man. Come on. All right. Now we see that we have the dy's in the numerator on the left. So then we just multiply the right side by dx. And so we'll get 5y dy is equal to negative x squared dx. Now we integrate because we have the y's and x's separate. And from here, we go ahead and use the reverse power rule. We'll 5y squared over 2. All right. Equals, gotta get low. Equals negative x squared, negative x cubed over 3 plus some constant c1. Get rid of this 5 halves. So multiply both sides by 2/5. And we'll get, hey guys, your y squared is equal to 2/15 x cubed, and this will be a different constant, plus c2. Then we just square root it, and we'll get y will be equal to square root of 2/15 x cubed plus c2. Man. Almost ran out of real estate. 2/15 x cubed plus c2, all under the square root. And there we go. Oh, my knees, I'm getting old. A side note, as I was looking at my textbook solutions, I remembered that sometimes textbooks have really different looking answers because they'll have like the y cubed and one side with the square root. I'll tell my students don't worry about that because that's something very formal that they might be leaving it, that they might leave it like that because they're gonna use it for another course and use it for like a higher level differential equations and blah, blah, blah. Don't worry about that in this course because differential equations get really crazy. If you stick around doing your math, that's where you go to like another math course, a higher level calculus, linear algebra, then you go back to partial differential equations, and that's basically the stuff you use for quantum physics and stuff. So it's fun. So stay tuned. Anyways, so three basic examples. I'll show some more difficult ones in another video. So just keep an eye out for that and let me know if you have any questions. Feedback is always welcome. Thank you for watching, and I will see you guys next time. Make sure you like and subscribe. Bye. Bye, guys. Thank you.